Alexis.
Thanks, Noah. Hey, folks. This is Tech Art 101. Quick intro of myself, if you're not already familiar. My name is Alexis Lapina. I'm a gameplay programmer at SkyMap by day, and by night, I am doing more game programming. But my favorite thing is tech art. I love making fun visual effects. These are some projects I've worked on. Folks who know me probably know Exalt, Camera That Bleeds, and Mech Game down here. But you might not know that I also worked on a VR rhythm game called Starwave that has a cult following, we'll call it. Um, and I've done a bunch of different random shader experiments along the way as well. So tech art. Tech art is, as a field, has like three different definitions that are used by varying people and by varying job postings. But overall, technical artists bridge gaps between artists and engineers. Generally, the unifying core of a tech artist's skill set is the ability to make tools for other people. Tech artists either on one side or the other improve the ability for artists to get their art from their editor into the video game and have it look nice in the video game. One version of that, and probably the more common version I've seen used in the industry, is the technical animation side. Many tech artists with this role do a lot of like skeleton rigging, skinning, some runtime stuff like cloth sim, in-game animation playing, and like state handling. If you've ever like worked with like animation like state machines in Unity or Unreal's animation graph, animation blueprints. That's a pretty tech art oriented thing. Anything that handles blending between like moving and like attacks, or like head look or inverse kinematics to make sure that your hands touch walls or that your feet touch the ground. That's like the technical animation side of tech art. And then there's the VFX and material side of tech art, which is what I am more familiar with and what we're going to be mostly talking about today. We're not going to be talking about too much graphics optimization, though I will mention it a couple times offhand. Mostly we're going to be talking about the fun stuff, the particles, shaders, materials, all the different things to make things look pretty in your game. Some core concepts that I feel like are useful as like part of your skill set and thought process as you're doing tech art related things. The first one is data is interchangeable. A number can mean any number of different things. For example, a common one is that a color, like a red, green, and blue channel, can also be a direction. You see this in normal maps. We'll talk about those a bit later. A texture can be an array. A lot of shaders can't take arrays for the programmers in chat, but they can take textures, and so you can use a texture to actually store like array-like information. For example, I'm using like a palette texture. Float can be any color if you have like ramps. These are just some examples. The more you're able to mess with data to turn it from like one type of data into another, the more powerful you'll become as a technical artist. Another is there's no one right way to pull off an effect. This is true for a lot of things in game development, but you can pull off an effect in a number of different ways, depending on what your specific use case, how the player is going to be able to see it, what your skill sets contains, and it's useful to because sometimes one way that you might do it might not work. So broadening the number of like tools that you have at your disposal makes you more flexible and versatile when making visual effects. Another one, thinking about the context that your visual effect is going to be seen in. Games of smoke and mirrors, we all know that. Taking advantage of that as a VFX artist will be to your advantage. For example, when and where are we going to see this effect? Is it going to be a quick thing? It's going to be a thing that sticks around for a while and like the player can futz with, get close to. Is it only visible from a distance? Then you can do a lot of cheats. Like you don't need to make it look good from the side if they're only going to see it from the front. If it looks bad in certain conditions, are you able to just not show it in those conditions? For example, like snow particles can, look bad if they get too close to the camera. Can you just fade out the particle if it gets too close to the camera? Most games do that, and it looks fine. People tend to not notice if you hide something. And finally, I hope you like math, because there's a lot of math going on if you're ever interacting with materials and particles and stuff like that. Really, what you're doing is using math to make art, and having a good grasp of what math functions can do will be also to your advantage. You don't need to like be a math genius, but you need to learn how to use math tools, even in at least like a vibes-based way, which is easier than you might think. So what I'm going to do first, I kind of changed directions since writing the summary of this talk. First, we're going to go through like a bunch of different things that exist. I've found that like a lot of people, when talking about tech art, visual effects, don't even know what tools they have at their disposal to create effects. And so what I'm going to do is I'm going to go through a bunch of different things at a very surface level that engines tend to offer, and that you can use in different ways to create different visual effects. So first, texture. We all know what a texture is. If you don't, it's typically a 2D image that stores data. Often, this is just a color image. That's probably the one you're most familiar with. But they can also store things like normal maps. I mentioned that a color can also be a vector. A normal map stores surface details to allow a surface to appear like it's shaded and has some like depth to it. In reality, the actual mesh might be a plane, like you see here. Like this would be like rendered on a plane, just like two triangles. But we're using the X, Y, and Z channels to store what direction a pixel is pointing in to allow lighting to interact with that surface. So that's one way in which you can mess with, the data you have available. Textures also have filter modes. This might be something that you've seen if you've ever tried to make a pixel art game in Unity back in 2018 or whatever. I don't know if it's the case still, but you'll import your pixel art and you'll drag it in and it'll be all blurry and you'll be like, what's going on? That's typically bilinear filtering, which is a common texture filtering method to take a zoomed in texture that might be like jaggy, and to smooth it out a bit so it looks a little less, sharp. You can't see the pixelation as much. But with pixel art, you want to see the pixelation. So that's one thing to be aware of. Textures can also be compressed to save storage. This also might have messed with your pixel art if you worked in Unity in 2018. Compression is very important, partly because textures take up a huge amount of game space. You might not realize, but most modern like AAA games are over 50% of their file size is textures, because textures increase in memory footprint pretty fast. If you go up, if you like double the size of a texture, you're actually quadrupling its memory footprint. And so like its memory footprint tends to increase like quadratically as you increase your level of detail, which is part of why games are so huge now. So learning how to compress your textures, what textures you can compress and what you can't, it's very useful. Obviously, like pixel art, you might not want to be all JPEG'd, and especially if you're using textures to store data, like a palette, you don't want compression to be messing with that. Textures, I already talked about normal maps. There's also a thing called mip mapping that happens, which is a technique to improve how textures appear when they're zoomed out. Filtering is often used when you're zooming into a texture, but if you see a texture from a great distance, without mip mapping, you'll often see like flickering because the texture is so like miniaturized that you're seeing like flickering between like the black and white, here for this, for example. And so mip mapping is a way for the game to pre-compute lower resolution versions of a texture that are kind of more smoothed out. And black and white checkerboard will tend to look more gray if you see it from like a bird's eye view. And so mip maps let you do that. One piece of terminology that you might come across is texel. A texel is just a pixel on a texture. The reason we use this word is because a lot of times when you're doing things in graphics programming land, you will be talking about rendering a texture to the screen. And so you're going to want to talk about the textures pixel separately from the screen pixel. And so this lets you refer to, the pixel that is on the texture differently than the pixel that's on your screen. It's also commonly used, you'll probably see it most commonly used when talking about textile density. This is essentially how detailed the textures in your game are. This is often measured in like texels per meter or texels per or like pixels per unit, because if you have mixed levels of detail here, you might notice like if you've ever like modded a game or like go out of bounds, you'll see like the textures on the ground are like super low res compared to like your gun texture or something like that. You want to avoid that kind of thing in most intentionally designed areas. Let's get a little more into the nitty gritty of what you can do with the texture. One technique is called channel packing. So textures, as I've said, tend to store between 1 and 4 values in like red, green, blue, and alpha, which is like how transparent your texture is in each pixel. But you can use those channels to store whatever you like. A common one that I've seen is called an ORM texture. That's short for occlusion, roughness, metallic. But really, you can use this to store any like 0 to 1 value texture as part of like your physically based rendering, or store whatever quality of the surface you want in your texture, all in one texture. Here, for example, like this texture uses the red channel for ambient occlusion, green for roughness, red and blue for metal, and that's all crammed into one texture. One example I'm doing a mech game, I'm using the red channel here in this render target for rust. You can see here, that's rust. Green is the mud, and blue is paint. And so whenever you're like cleaning up the surface, I'm just affecting that one channel based on what tool you're using. A little more complicated. We can go deeper. There's a concept called bit packing. Engineers in chat might know a bit more about this one. So textures have color depth, or colors have depth to them, which is how many grades of detail you have. A common one is 8-bit, which gives you 256 degrees of texture color. If you ever worked in like an image editor, you see like your image, your color is represented as like 0 to 255. That's this. You can use that data however you want, though. That's 8 bits that you can mess with. Here, I'm using 5 bits to store a palette color, and that's indexed on this like texture. Here, each row is like a palette that I can pick from, and I'm using the remaining 3 bits to store like 8 bands of opacity. This gets very, this is maybe a little, technical, but this just gives you an idea of like the types of things that I mean when I say, you can use data however you want. And the more that you can exploit the data that's available, even down to the ones and zeros, the more capable you are of like getting a lot of like juice out of your what tools you have available. Stepping away a little bit to just enough talk about textures, even though billboards are basically a texture. A billboard is just a texture that faces the camera at all times. This is common in like here we have like sparkles, and you can see these are always facing the camera, these little stars. But you might not like notice that until you like looked closely or thought about it too much, because these stars look nice when they're always facing the camera. But if you have like a weirder texture, like if this was like a rock texture, you might notice like, oh, why is this rock like looking at me all the time? So billboards have what happened? No. Billboards have their use cases, but you can get a lot out of billboards. For example, the explosions in Helldivers, for anybody who's played the recent Helldivers 2, look pretty dang good, even though they're like mostly made out of billboards. You can actually notice this if you like get really close to an explosion. You can see like the billboard like turning to face your camera, and like even like clipping into objects a little bit. None of my friends noticed this, but I'm a freak about VFX, and I was like, oh, I wonder how they're doing this. And like you could have some volumetric solution to this. You could like spend a lot of, GPU resources on rendering all this like true to life 3D smoke stuff. But that gets really expensive. And when we're talking about visual effects, we're always going to be running up against like what machines can this run on? And so sometimes doing a low tech solution like a billboard is plenty good enough. And people love the explosions in Helldivers. So I keep pressing escape. I'm stupid. Stop it. I mentioned earlier particles. I'm not going to get too deep into particles because these systems are very idiosyncratic and very detailed. But basically, particles are a lightweight tool to remember complex visual effects, especially those involving a lot of things that are very similar. Rendering like, if you have like 1,000 game objects in your scene, one for each snowflake, that might cause Unity to have a tough time. But you can just have one particle system that, just spawns like 1,000 snow particles, and that's just one draw call. It runs fine and it does exactly what you want to do. You don't have to do all the, overhead that game objects tend to consume. These can be run on the CPU or the GPU. CPU generally gives you more control. You have more access to like game data. You're not, but it is a little bit more costly if you are like running on PC, I believe, because you have a graphics card available that you're not really using to its full extent. Whereas on the GPU, we're a little bit more restrictive. Oftentimes, GPU particle effects have like bounds that they're only allowed to work within, but they tend to be more performant if you have a graphics card. And these are super flexible. You can do all sorts of stuff with particles. Everybody thinks of like snow or like dust, but you can make these trail effects with particles. Like here, for example, Unreal Engine, I don't know about other particle systems, have ribbons available to particles that let you like connect different like particles in order with like a spline, and it generates geometry connecting them in this kind of smooth way, and it lets you create this kind of tube effect here that like drags around in mech game is a particle system. Even my hoses are particles, not like the physically simulated part, but the hose that renders is actually a particle system that uses a ribbon. And all sorts of stuff is available to particles depending on your engine. You can even spawn particles on the surface of a mesh, which can be useful if like you want to do that. I don't know. There's a lot of things you can do with particles. I'm not gonna get too deep into it here. Another tool available is scene captures and render targets, or cameras and render textures, or whatever your engine calls them. Basically, it's a camera and a texture that the camera can render onto. This is probably most obviously useful for things like CCTV cameras in games. Like, if we're playing like Five Nights at Freddy's or something like that, that might use like render textures or something like that. But you can use it for a lot of other effects if you get more into the different ways and things that you can render. For example, drawing on surfaces like Splatoon uses render targets for sure. And you can even use a scene capture camera that renders the depth buffer to do like snow like deformation. I'm pretty sure that's how it's done sometimes. Anyway, again, won't get too deep into how these things work and like what you can do with them, but they're there. They're fun to play with. I recommend them. Very fun to have another camera floating around. This is my favorite thing, shaders and materials. This is where I do most of my work, and what we're gonna be like the little sandbox time after the presentation. I'm gonna be like showing off and explaining my process. Shaders and materials tell your graphics card how to display an object. Technically speaking, a shader is a set of instructions sent to the GPU as part of the rendering process. Like a material will have a bunch of different shaders inside of it. There's like the fragment shader, which renders like the pixels, and there's the vertex shader that tells the graphics card where the vertices are, and you might want to use them for different reasons, and they're sent to different stages. But I'm not going to get too far into that. This is how you describe what a thing looks like, and they're pretty dang powerful, and every engine has one. Blender has a material editor. Unity has shader graph. Godot even has visual shaders, and Unreal has material graph. I have most of my experience in Unreal's material graph. I'm not sure about the limitations and features of the other ones. Most of my knowledge is in Unreal, and I'm going to be showing you guys Unreal's material graph, but I'm pretty certain that most functions available in Unreal's material graph are available in other ones. I see a message in talks text. Oh yeah, render targets are awesome. Big fan of those. I love drawing to stuff. What's fun with render targets is you can draw to it and then have a material that reads from it and then draws to it again. So you can have these fun, you can make like simulations in a texture using a render target that like just draws to itself and references it like its previous frame's state. Anyway, I'm getting too far into it. But yeah, I highly recommend if you're interested in tech art, visual effects, shaders and stuff, to take your favorite engine and crack open its like shader editor and start futzing with it. At least Unreal's material graph, I'm not sure if Unity's and Godot's are as friendly, but they're very accessible and easy to play with. You can just like output stuff and to like see how it works. You typically get immediate visual feedback on your changes if like maybe waiting a couple seconds for it to compile. And like there aren't really that many limitations to these unless you're doing like crazy graphics engineer stuff like writing Nanite or Lumen or whatever. Each one does have its own learning curve. Like I'm pretty dang good at Unreal's material graph, but I tried making material in Blender and I could not figure it out. So, you know, it'll take some time to get comfortable with the tool, but there are plenty of good tutorials out there, especially for Godot and Blender, you know, with their recent popularity. So yeah, material graph. Some tricks. I don't know. I don't know what I'm doing this presentation. I'm kind of just talking about stuff I get excited about and things that I find useful. Easy one. The emissive channel is great. Emissive is like basically how glowy your surface is, and it's available in most like material domains, whether you're transparent or like an opaque material. And you can overload the value. For example, here, like this is like regular old 1 like to the emissive channel, like red multiplied by 1 looks pretty normal. Multiply it by 100, gets a little brighter, and you can multiply it by like 1,000,000 or whatever, and it gets crazy bright. This is great. Really easy to slap like bright, glowy lasers and like missiles and slashes and other visual effects in like in a game jam context with the emissive channel, because it's just we love lights. Glowy stuff looks great. Another technique, triplanar mapping. This is how a lot of like environment artists like have like grass being on the top of objects but not on the sides, or like snow on the top and not on the sides. Yeah, I haven't done it too much myself, but it's out there if you're interested. Decals are also a thing that exists. This is in the materials section because you can put a material on it, but this could be on its own slide. These are great and very versatile. You can use them for like graffiti, but also for like fake spotlights. You can use it for like blood splatters, like bullet holes in walls are typically decals. Other things that you might want projected onto a surface are great for this use case. Let's see. Yeah, Fresnel, I think it's pronounced, is like if you've ever played like an old video game that has like, you know, pickups that like glow on the edges, that's typically a Fresnel effect. But you can use that for other things like blurring out the edges of objects if you want them, if they're like curved and you want them to like be a little more smoky. Like this is just a regular sphere, but I'm using a Fresnel effect with some math like on it to make this like kind of fade out. And that's pretty simple. You just do like a dot product with the camera. I'll talk about some math later as well. So if you don't have a Fresnel node in your material editor, you can just do a dot product with the camera vector. Light functions are a thing that a lot of frack. It's pronounced Fresnel. I'm gonna cry. Light functions, I think most engines have available, and they let you basically like put a texture on a light so that you can like fake shadows and stuff like that. It's great if you want like a spinning fan, but not to have like an actual fan geometry right there, or if you're worried about like shadow casting performance because casting shadows can be at runtime can be a little heavy, um, or if you just want like a weird uh, shadow shape that and you don't want to bother, lining up your spotlight with like the window just right. Um, yeah, you can even some engines. I think if you enable it in Unreal, you can have colors on these, which is great if you want like a stained glass effect. Like, anyway, rambling. Noise is one of my favorite things to play with. I kind of hate writing my own textures for stuff, especially if I want them to like tile nicely. Um, and like I don't want to like UV unwrap stuff. So I just like use noise in world space. This uses like a world space, um, like a 3D like I think Perlin or simplex noise. There's a lot of different noise types you can tap into, and you can like scale it up and down, and you can like mess with the output of noise to generate different like effects. Like you can make lightning out of this. You can make smoke. You can make like water. Um, any like natural pattern. You can just like use noise with. Um, and the nice thing about world space noise is that if you have two different objects, they can like intersect here. Like you see this pattern kind of like maps onto the other one. That's just because of how world space noise works. I mean, like these are at this practically the same position in world space, so it makes sense that they line up. But it's pretty handy if you're doing like, environment kit and you're like kit bashing a bunch of different like rocks together and you want them to like kind of match up. Noise can be using noise to like inform your color and material quality can be useful for that. Another thing that's very useful and I didn't learn until way too late. You if you're having problems with like your effects, especially your transparent effects, like clipping into objects and making these like ugly, harsh edges, you can just depth blend because transparent materials have access to the depth buffer. Unreal actually has its own node for depth blending, but if you don't have it available, you can just read from the depth buffer, compare like the pixel depth to the like scene depth at your current pixel, and blend on that distance. And it really helps. Oh, you didn't know that? Well, learn something new every day. I'm glad this presentation has helped somebody. Yeah, depth blending is great. Awesome. More material stuff. Post process. I don't have time to get into all the things that you can do with a post process material. But basically, what a post process material is it's a shader material, whatever, that runs after your scene is rendered. And if you're using like a deferred renderer or like a fancy forward renderer or whatever, you have access to all these different like textures based that like rendering the scene output. Like obviously you have the color, but you also have like scene depth available to you. You have scene normal. You even have things like velocity, which you can use for like Unreal Engine's like motion blur uses the velocity buffer, I believe. And so you can actually like output values to the velocity buffer in like the shader, I think, to make it look like you can have this like force effect, or you can like counteract like the motion blur by like setting the velocity to 0 on the surface shader. Not exactly sure how that works. Anyway, there are a lot of different buffers available to you in the post process that let you create all sorts of different effects. Camera that bleeds, for example, and a lot of games with more cartoony visual style use post process effects like pretty much across the board because we're building on top of like modern render pipelines that are physically based. So we have to like do the crunching the render down to like being more simple after the scene is rendered because it's just easier. But yeah, you can use things like what we use for like the outline shader here is we basically compare the like um, both the normal so that you can like detect like edges if the adjacent pixels like have a different enough normal from the current pixel, or you can and we use the depth buffer to compare the depth of adjacent pixels to the current pixel to see if there's like an edge there, and if there is an edge, we render a line. Um, And also we use post-process effects for this like cell shaded lighting thing. You can extract, if you don't have like a lighting like buffer available, which often engines don't, you can just take like the pre-lighting and the post-lighting passes and like compare them to each other to figure out, for the most part, like what areas are lit, how much. Um, anyway, what else do I have here? Oh yeah, there's also a thing called the this is called a number of different things depending on your engine. It might be called custom depth in Unreal. I think it's called stencil buffer in Unity. Regardless, this is a special buffer. Oh, I should say, I don't know if I said this, but a buffer is just a texture. It's just graphics engineers need their own fancy word for it for some reason. I'm not exactly certain. But yeah, custom depth is great because by default, nothing renders to custom depth. But what you can do is you can tell like a mesh, hey, I want you to write this value to the custom depth buffer. And that lets you see that thing like through walls, basically. It's great for like anytime you've seen like a, X-ray effect, like here, you can see like the tubing and the hydraulic cylinders inside the mesh, inside this leg. That's using custom depth. I'm writing like different values to custom depth, and like I talked about earlier, the custom depth buffer, at least in Unreal, you can write to specific bits so that different values don't like destructively interact with each other. I won't get too detailed. I've been on this slide for too long already. Talk to me if you wanted to do post-process effects. It's a very deep field, but it's really cool. So one thing with materials that had me stumbling a lot for a while is how the heck do you like actually like figure out what's going on in a material? If you're, an engineer, you might be like, oh, just put a breakpoint in your material. You can't do that. Your material's being run on every pixel. It would be crazy to put a breakpoint in there, and it's just not supported. You can't like put an output log because like you just don't have the same debugging tools available to you. So you have to do other things. One thing that I do is I output like a value that I'm suspicious is misbehaving, or that I don't quite understand, to the base color node, the base color output. Like for example here, I'm just outputting the texture coordinate to base color. Texture coordinate goes from 0, 0 to 1, 1, and so yeah, that's why it looks like that. This is part of what I mean by like being a good tech artist is understanding how data can mutate. Turning a texture coordinate into a color like might not make sense to you at first, but you kind of develop like an understanding of, oh, this is like what I should be seeing here. If I do an add, if I subtract 0.5 from this, then it should move that position down here. If I do radial coordinates, you'll see this. This is basically how I debug my like materials. Like if something's misbehaving, I'll just be like, I bet something is looking wrong in this like specific like area. And you can typically output it directly, at least in Unreal. You can output scalar values like just a single float like here. This vector converted to angle thing is just a scalar 0 to 1 value, and that's part of why this is like black and white. This is like a vector 2. There are 2 floats here. That's why it's like red and green, and there's no blue. I think most material editors probably work that way as well, but yeah. Another tool is graphing calculators. Welcome back, high school. I love graphing calculators. They're like, I just use Desmos, honestly, which is like a free online graphing calculator. And it's great for visualizing like what math you're doing. Because like I said, you're gonna be doing a lot of math here. You might be using sine. You might be using like exponents and like, weird like functions that you haven't heard of before. And so just like putting some stuff into here and trying to create like a curve that you want in here, and then like going back into your shader editor and like building that. is a big part of my process when I'm doing like really weird visual effects. Another thing is making sure your outputs are in the 0 to 1 range. Is like generally a rule that I keep across the board when I'm doing like visual effects, because if it's in the 0 to 1 range, you can just output it to base color and you'll see the full spectrum. If you have a value that's like 200, that'll look exactly the same as 1 will if you output it to base color. This might trip you up if you're working in the depth buffer. Might output depth and be like, why is everything white? Or why is everything black? It's because every pixel in the depth buffer has the distance to that pixel, and if the distance is like 200 centimeters, it's going to be 200, and that looks the same as 1 in base color. So you can use things like the remap range node. You can just divide the value. There are a number of ways to like get your output into that 0 to 1 range. If it's a vector, you can just normalize it. Let's see. Here's some math that I like. I hope you like math. I have come to love it. Like I said, normalize your floats. It's just makes life a lot easier, and a lot of functions just work better in the 0 to 1 range. For example, the power function, if you like put something to an exponent, it's great if you're working in the 0 to 1 range, because your 0, 0 point and your 1, 1 point will be exactly the same no matter what power you're using, I think, unless you're using like some unreal number or something like that. But yeah, you can use, here I'm like sliding the power from 1 down to like a fraction, like here it's like 0.3, and then up to like 2. Basically, it lets you kind of nudge your in-between values between 0 and 1 in one direction or another. So if you want like whites to start coming in like later, like if you want it to be like darker and then brighten right at the end suddenly for like a color ramp, you might do that. Or if you want it to be like get bright really quickly, you might want to do like power, like basically square rooting. Yeah, let's see. Step function. Step is fun. Step just like outputs 0 if A is less than B and 1 if A is greater than B, or vice versa. I forget. It's great if you want like a hard cutoff between values, but often that looks pretty bad. You get like alias lines. So what you can do is smooth step instead. Smooth step produces like a sigmoid, an S-shaped like curve that goes between like 0 and 1, based on like starting and ending values. So like this is like starting at negative 0.5, ending at positive 0.5. We want to like do like a smooth step so that we have a nice like easy ramp between these two values. Fmod is very useful, especially for like tiling materials where you want to like, you know, like repeat a texture over a surface. But obviously like depending on the way you're sampling the texture, like you need that like your texture coordinates to be between 0 and 1. You can use like fmod. Fmod with fmod on 1 is probably my most commonly used one, because it just gives you like a fractional component of a number. Yeah, and it's basically like the remainder. If you haven't heard of the modulo operator, which many people haven't, it just gives you the remainder of like a regular division. Some trigonometry stuff. Dot and cross product are not as scary as they might sound. You know, we're talking about vectors, but you can use these in vibes-based way. Dot product of two vectors is a great way to just tell you how closely aligned are vector A and B. Like right here is a visualization of dot product. It's 1 if they're perfectly aligned. It's a 0 if they're perpendicular. And it's -1 if they're pointing away from each other. And this is great if you want to like, you know, like I said, Fresnel effect, whatever. Or if you're doing like, you know, gameplay code, obviously this is also very useful, but we're not doing gameplay programming, we're talking about graphics. What am I talking about? Cross product, on the other hand, also maybe scary to some people, but it's not that complicated. It's a little similar to this. Thank you, Matt. And cross product basically returns a vector perpendicular to the two vectors you're passing in. with a length based on how close, how like perpendicular those two vectors you're passing in are. There's another visualization here for that. You can Google that. I didn't have space on this slide. And finally, lerp. Lerp is fun. It's great if you want to like smoothly transition between two values, whether they be like, you know, floats or two colors. And you just like have it transition from A to B over X, where like if X is 0, its output it's A, and if X is 1, it output B. And if it's like 0.5, it's like right in the middle. It's great for those like really smoothly transitioning. You might use smooth step with a lerp. That's pretty common. I do that all the time. And finally, like I said, remember your context. Your effect doesn't need to look awesome in every condition. Think about the conditions that the player going to see it in. Are they going to get close to the effect? Are they going to be far from it? Can they swing their camera around? Yeah, I already talked about this. I don't know why I had this slide in. Yeah, I have some time. At this point, I was gonna open Unreal and like just go through some different, like, show you my process in real time. But I'm happy to take questions as well if people want to ask any. Honestly, I might just like get started and people can ask questions as we go. Oh, let me change my heck. Let me make this look better. How much experience do you need to get an entry-level tech artist job? That's a great question. I don't have one, but and I couldn't tell you honestly. I feel like anything I told you would be me making shit up. I don't know if I can say shit. Making stuff up. I do think that having a strong portfolio, as usual with game jobs, is like kind of make or break. And so like doing tech art stuff on, you know, your like school game projects, and having a decent portfolio of different visual effects of different like, you know, fun tech arty stuff that you've done is probably the best way to like strengthen your chances at getting a tech art job. And I have seen some like internships and stuff like that. But anyway, neither here nor there. Hope that was helpful. Let me change. What is it? Change stream, Noah?
Yeah, I think it's you should be able to right click and then change stream and then
Gaming.
get into the cog, yeah.
Yeah. Okay. Cool. Now this should look better in real time. Are we smooth?
Oh yeah.
Let's go. Cool. So what I was gonna do here is I was just gonna like make a simple effect really quick. Let's just start from scratch, honestly. Get out of here. Do I have a holy grail effect that you've chased and still have not been figured out to make? One thing I really want to do is I want to figure out parallax occlusion mapping. Where like you ever see those like space crystals that like you know, look like they have like an infinite amount of depth to them, but like in actuality it's just some like shader math. That stuff is so cool, and like I've just not set aside like a couple afternoons to figure out how that's done. I'm pretty sure it's not too complicated, but it looks so cool, and I really want to do it sometime. Anyway, I'm thinking. So I just was thinking it'd be easy and it might be a fun exercise to just make a shockwave effect. So we're gonna start this from scratch. First, I'm gonna do a vector to radial. Heck, this is harder to do in real time. My brain isn't working anymore. Vector to radial value. There we go. So this is texture coordinate. Again, this is just 0 to 1. One thing with textures is that UVs are positive x in the right direction and positive y in the down direction, which might be a little counterintuitive for some people who might assume like positive y is up. I'm going to do vector to radial. Let's see. Now this looks a little boring, but if we subtract this to 0.5, so 0, 0 is in the middle, this should be, yeah, there we go. Yeah, so this is a value. You can also just like with just math if you use like arctangent. I won't get too deep into that here. But basically we're just converting like uh, regular Cartesian coordinate space into like radial coordinates. And that lets you do like radial effects. This is basically the like angle, and then this is the distance out from the center. Um, I can another thing that's useful is time. Most material editors make time available to you. You can use this to like do and often I'll use fmod with time. You can see the output of time here. Um, and you might be a little bored because it's like, oh, why is that just white? Because time is probably like, it's the number of seconds that have elapsed since I opened the engine. So it's probably like several thousand, but it's just outputting one, which is why you want fmod. You can use fmod with one to have this go from 0 to 1 every second. And so this will pulse black to white. And you can, there are a bunch of different like simple math operations you can do this to futz with that. You can multiply this by like 2 before it gets float modded, and that makes it pulse twice as fast. Or you can do it by half, and it pulses half as fast. And then doing a multiply afterwards just scales the output to be like brighter or whatever. So knowing when to do your math operations is a big part of and how that will affect your output is something I think you'll just learn by just playing with this. I really think that like with anything iterative, like iteration and playing with it yourself and seeing what happens when you do different things is the best way to learn, at least for me. And so honestly, just getting into like an editor like this and learning how to do basic stuff like searching through it, and like what different nodes are available to you and just plugging them in and seeing how they interact is like a great way to learn. Anyway, so we have like this, we have this that goes like, radially. And we have this that pulses. What if we do a step function on this output? And I wonder what that will do. Whoa. If you've seen my recent art, my recent posts in project sharing, you might recognize this. This is how I'm doing my timer on the like Rust laser. I can actually like play that right now. I forgot that this is a mech game. But yeah, this effect is just that. I'm just doing like I can actually like open the material probably, but you get the idea. Very useful. Learn materials. It's really fun and powerful. What was I doing with this? Oh, I was gonna make a shockwave effect. So we can do it instead on the linear distance, and then we have this pulsing thing. But obviously this is a pretty sharp, like outline. We're gonna want like a more gradual, smoothed out effect. So let's do. Here's the function I didn't talk about. Sine. You might remember this one from trig. So sorry. If we just do sine on linear distance, you'll see it starts off like black in the middle, and then it becomes like white here, and then it becomes black here. And if you open, let's get Desmos open. Y equals sine x. This is what we all came here to do. This is why we got into gameplay programming, to do this. So I think sine actually outputs like anyway, you've seen this before. I think it actually outputs like, I think it actually maps it onto 1. I actually don't think sorry, I'm learning things about Unreal now. If I multiply this by 2, it should just go back to, yeah, okay. Yeah, trig is fun. Trig is fun. It's not scary. You don't have to do the actual math. You just need to like know how to use the functions. Thankfully, graphics cards just do all the computation for you. The computer does the math for me. Yeah, so at least in Unreal Engine, it looks like the sine function outputs doesn't do any like pi stuff. It just like outputs like over at 1. and like 0.5 and stuff like that, which is very useful for us. We don't need to involve pi at all here. It makes this demo a lot smoother. Anyway, if we just, honestly, because sine is cyclic, it just goes on and it looks like this forever. We actually don't need to do any fmod here. We can just pipe like time in directly. And if we just like add these together, adding time or if fmodded time to a value is great for doing this kind of like, ooh, you're getting very dizzy effect. Sorry, I should probably put like a warning. It's already 8. Dang. I don't know. I might just keep doing this. I don't know if anybody has any questions or wants to talk about this.
You got time. Feel free to keep going.
Cool.
We don't have like
yeah,
a hard
right.
cap at 8 at all.
Sick. All right, so unfortunately, this is not doing shockwavy stuff because it's radiating outwards. Or it's not radiating outwards, it's like pulling in, which might be cool if we want a pull-in effect, but we don't want to do that. So if we just negate, just multiply time by -1, then it should just go in the other direction. Yippee. So other thing is, this might be a bit of a large like shockwave. What if we want to like make it smaller? Well, what you can do is one thing you could do is you can multiply right here. Actually, this might not work because of fmod, and this is going to be a really big number. What if we do 2? What happens? Okay, well that's going faster. We might not want that. Heck. I'm kind of not sure what to do with this tech demo. Does anybody want to see me do anything? Let's throw some noise in. So with noise, one thing with noise is many engines and material editors just have like regular noise available. Like Unreal has, you can do simplex noise, you can do like Voronoi noise, all sorts of different like noise functions. But you can also just use a texture, and textures are great. Yeah, but let's stop with the hypnotize effect really quick. Yeah, thanks for hanging out, Rob. So if the nice thing about textures is you can just like have a texture that tiles, and that way, you don't have weird like edge, like intersecting effects. Let me show you what I mean by that. So here, like we have this. Let's set that aside for now, and just output our noise. So noise samples world position automatically. This just looks like static. The thing you want to do there is just like change the scale. You can do this by multiplying the world position, or you can just futz with like the node here. Actually, let's make this exposed. Let's do text chord. You could use world position for this, or you can use a texture coordinate. That will change how it affects how it looks based on like if it's like moving through space. You might want the noise to like stay local to your texture. You can also use local position. Anyway, different options available to you here. But let's just use a texture coordinate for now. Now this is giving me an error. First time we're seeing an error because we're trying to cast a float 2 to a float 3 because this expects a 3-dimensional position and this is a 2-dimensional position. Pretty easy. You can make a float 3 and then break a float 2. Most engines probably let you just do this. I'm sorry if this all ends up being very idiosyncratic to Unreal Engine. But like I said, most of these material editors are pretty similar. They all have these nodes, they all have vectors that you pass around. Some of them actually like have coded like wires here. Unreal doesn't do that. You actually kind of don't know what like this is until you plug it into something and it tells you, oh, you can't do that here. That's a vector 2, you idiot. So that's just something you'll have to learn. Oh, this is fun. So I have turned this vector 2 into vector 3. The z, I'm just leaving 0 because who cares? But one thing you can do is you can use whatever you want in this z. And if you give it time, you can just have it, ooh, whoa, it's doing some cloudy, noisy stuff. Obviously, you can scale time. If this is going too fast, we can dial it back a little bit. Nice smoother, uh, cloudy effect here. And the reason I want that is because like a shockwave tends to not be like a clean ring. This might be a little too like kind of boring. And so we might want to multiply this by this. Oh, that looks weird. Something weird is going on. This might be because I'm not outputting a 0 to 1. Yeah, this is negative 1 to 1. So there might be, oh, what's happening is sine outputs like 1, like it takes like a arbitrary x and it outputs either 1 at the peak of the sine or negative 1 at the bottom. And this noise is designed to output a negative 1 to 1 range. And so the negatives are multiplying by each other and producing a positive. And so that's why you get this weird invert effect. Anyway, this is why remapping things to 0 to 1 is useful, because otherwise stuff like this will happen. Unreal just has a remap normalized function that lets you pass in a range. I tend to just use like a vector 2 here. And you can just be like, I want negative 1 to 1 to become 0 to 1. That's what normalized means, at least in Unreal Engine. Is like, now, this might be too like big of an effect, but we've made the shockwave a lot larger. But now these are all 0 and 1 values. And so when we multiply these, now it should look, well, maybe that's not quite what we wanted either. No, that is what I wanted, because this shockwave is so dang big. How do I make it little? What if I remap like 0.9 and to 1 to 0 to 1? Oh yeah, there we go. Now we got a shockwave. I'm kind of figuring this out in real time as well. I actually don't know if this is still outputting 0 to 1, because I don't know if this is clamped. No, it's clamped. Okay, cool. Yeah, the clamp is another thing. If you're not sure that your value is behaving and staying in the 0 to 1 range, you can always clamp it. I tend to do that aggressively. Yeah, this is fine. Obviously, this is opaque. Like, we don't want this black like rectangle here. I actually didn't talk about blend modes very much in my presentation. That's fine. Masked. We'll go through them really quick here. Masked materials are opaque, but you can pass them a texture or a value that tells it where to be fully translucent. This is often used, like, it's often called like alpha cutout. Oh, this looks really weird. Let's simplify this a little bit. Yeah, cool. Yeah, basically one, it takes the value, and if it's 1, it renders it, and if it's 0, it doesn't. I think this does a step function behind the scenes. I don't remember what the like clip value is, but who cares? We're not gonna be using masked because we want this to be like a glowy, shiny effect. Another blend mode is translucent. This one lets you, make glows, but also like dark stuff is common for like smoke. Let's just pass our noise into the base color here and opacity. Yeah, it's translucent. I guess we could compare translucent to more restrictive blend modes. Additive, for example. Additive basically adds the pixel output to the screen. Let's just define like a color here. We want our shockwave to be like, let's do a fun blue one. Additive can only add colors to the background. So if like we define this as black, suddenly we can't see it anymore. You can see it briefly there because I'm not passing any color in the base color, and the default for base color is like gray. But if you add zero to a color, it's always zero. So additive isn't great for like bright environments, but it is great if you want like, explosions or glowy effects, um, hit effects and stuff like that. What am I doing? Blue. Yeah. So this might be what we want to do for the shockwave effect, actually. Now we're getting somewhere. Unfortunately, this shockwave keeps going to the edges of the plane, and we're kind of seeing like, oh, this is just a quad. It's not a net. It's not a shockwave. So if we do another multiply here, also I can just keep doing this forever. I don't know if there's a hopping point. Um, I don't want to bore people out of their minds and have them leave when they get bored, but um, let's just do a smooth step. And then just like have this be based on the distance 0.4 and 0.5 because this linear distance, let's output this so that we see what's happening here. Linear distance, opacity. The only thing is with working in like this blend mode is it's kind of hard to see what you're working with. So if let's just go back to opaque material and just output these things to base color. So go away, emissive. Here's another learning opportunity. You can look at this and be like, I don't know what any of these numbers are. This kind of looks like it might be 0. This kind of looks like it might be 1, but it might also be like 0.5. Step function. Step function can just tell you what color is where. Like 1, this will produce a harsh cutoff at 1. Okay, so we didn't have any 1s there. Let's do 0.5. Aha. So this is where it goes from like less than 0.5 to larger than 0.5, or vice versa. So this is basically how I do a lot of my math debugging. This is a great way to do like an output log or like oh, got here, you know. I forget what I was doing. Oh yeah, 0.5. So at 0.5 we have a nice circle. So if we do a smooth step here, okay. Here we can use the 1 minus node. Actually, I don't know if we want to do 1 minus here. If you want to, if your smooth step is like where you want it to be, but the colors are flipped, you can also just like flip these parameters for the minimum to be larger than the maximum. You can do this with a lot of nodes, and it just like works. And voila, you have flipped the colors. So this should. Ooh, stop using the emissive channel. What are we doing? All right, now we have a nice shockwave that stays, that stops from the effect hitting the wall here. Let's see. Let's go back to just so that we can see how this would look. Wait, what am I doing here? No. Multiply. I forgot. I forgot. Okay, that's fine. It's a little too it's a little too dark in those like dark areas. Let's like change this. Oh, this is going to -1. If we start at 0, if we go from 0 to 1 in the output, yeah, okay. We still got some noise. Yeah. Another thing you can do with noise, you can also remap the output, like we did here. Let's see. Let's go back to opaque. Yeah, you have regular noise, but you might want your noise to like scroll outwards from the middle. Like we're making a shockwave effect. You probably want like the smoke looking effect to like move outwards to carry some energy. So let's do that same remapping thing we did. We have these radial coordinates here. So we should just be able to pass these in here, right? Oh, well, what the heck's going on here? What is this line? Well, Noise, at least this one, doesn't tile. Some of them tile. I tried using a tiling one. It was confusing to me. I don't want to worry about that right now. We'll just go back to using a noise texture. Noise. Unreal, thankfully, comes with a bunch of these. And they take up a bunch of my freaking file storage. But it's handy to have around for something like this. If we just output this texture, which should tile. Please work. Oh. Oh, right. This takes UV. It's not a 3D texture. What am I doing? Okay, cool. What the heck is this? You might see this line of pixels here. That's like what are these dots here? This is because of, I think, UV mapping. If we just do absolute, I wonder if this, yeah, you can see if I change the MIP mapping mode to like just absolute, this defaults to like only sample the regular texture. It looks fine. What's happening is Unreal and many engines do a sort of computational MIP mapping thing, is detecting here there's a discontinuity where if we output the radial coordinates, you can see like it goes from 1 to 0 here basically in that like green red channel. It's detecting that and it's being like, oh, the texture is really small here. Let's sample like let's use a different MIP level. I think that's what's happening. I'm not sure. In Unreal, fix is you just can expose the derivative, which, hang on. I'm getting, this is a very Unreal specific issue, but it's fun. Hang on, let me look at chat. What's going on here? Distortion effect. That's a good, that's a good one. Let's throw it. Let's stop fussing around with this. Let me just solve this actually. Throw away regular noise. Go away. ddx, ddy. This just computes the derivative so we can tell. I don't know. I'm not exactly sure what this does actually. I actually don't know if this is actually going to fix it. Are we having fun? Is this still fun? Ah, frack, that didn't fix it. What if we just used the raw text chord? Cool. Fixed. Yippee. I'm God. What was I doing? Oh yeah, ripple effects. Yes. Transparent materials have access to, let's go back to additive. Can we do, it might be a translucent thing. Offset. Heck, I'm trying to remember which one lets you do that. It might be a thing I have to enable here. I wish I remembered what it was. Rats. There is a post-process effect for it, but you can also do it in the, actually I have it in my laser tool. In this smoke, you can see a little bit of distortion. Let me see. Laser. Smoke. I think this one. There it is, refraction. I don't remember how I got this, but Unreal at least like just gives you like a refraction output. And like if I like put that material just on this quad here, yeah, you can kind of see it a little bit. It's kind of distorting it. I can exaggerate it to be like a little stronger. Please work. There we go. Yeah. Yeah, you can simply have an engine that supports it. I don't know if this is available in Godot. I know you're working in Godot. But this will break some effects. like this doesn't affect your depth buffer. So if you're like if you're using like an edge like tracing shader, I know this because when I worked on camera that bleeds, I wanted to like futz with like this kind of distortion effect, and you're like it will detect your edge here, despite the fact that like you know yeah, your depth buffer won't be affected by this distortion effect. This only affects like I forget what scene textures this actually affects, but it's pretty fun. Thank you for mentioning that. This is also a fun and easy thing if your engine simply supports it. Yeah, let's see. Are there any other fun things here? Anything else people want to see? I don't know. I'm kind of drawing a blank here. I could, yes. I just gotta remember. I think there's like a boolean you can just tick. Refraction. Ah, yeah, you can specify. Yeah, you can even like if you're doing like physically based stuff, you can specify an index of refraction for your material. Um, but we're just gonna do a 2D offset because that's pretty easy to understand. Rats, what was I doing? What's going on? Why is this broken? Additive. There we go. I don't know anything about compute shaders. I'm sure they're pretty cool. But also I don't know anything. Oh god, what's happening here? I think there we go. We're back to normal. Yeah, we're back. We're so back, chat. All right, if we output this to refraction, what happens? Oh, that looks funky. So let's slow things down a little bit. Let's turn off real time, or let's let real time go until it's like at a good. Okay, yeah. Heck. So refraction. This is like warping it, but it's not warping it like out. This is like just basically. This is expecting a two-dimensional offset, but we're like pushing in one direction. So I think if we get the like radial coordinate, I'm actually not sure what we do here. You might be able to just take this text chord minus 0.5. What happens if we? Ooh. I don't know. I would need to think about this a little bit more to figure out how to properly do a fraction thing. Maybe if we just change it to index of refraction and like pass in noise, and we'll just call that good. Um, multiply by noise work. Let's go back to real time. Well, it's not quite working like I wanted it to, because we can still see this edge here, but there is like a ripply effect happening. Anyway, I think I feel like we're getting to a point where this is getting less useful, but you get the idea. Thank you all for coming and listening to me yap about my favorite thing for an hour and a half. Happy to chat with anyone who wants to learn more about tech art, VFX stuff. It's my favorite thing to talk about. I will annoy you so much. And thanks for coming to my TED Talk.